this is important for us to know that yesterday when we were talking about the acceleration due to gravity. So let me just take one example here. According to Galileo's, there is 100 kg and 15 kg, let's say 50 kg object here, and they were dropped from a certain height. They were dropped from a certain height. Now, which one is going to reach more faster? In normal speaking, we are definitely going to point toward this side here, that is 100 kg. 100 kg is going to reach the ground more faster. But according to Galileo's, when he did an experiment, he somehow confirmed that 100 kg and 50 kg both will reach the ground at the same time. Why? Because the acceleration due to gravity for this and that is same. Now what is important, because when I said this particular point, I think many of you are not able to understand. Okay, you are not able to, what do you call? Like this is a common sense that this is going to fall more faster. But when Galileo was conducting his experiment, he conducted the experiment, in a house where there is no air resistance. The air inside that particular container is totally equal to zero there. So that means when he conducted a ball and a feather, you know feather, okay? Feather and a ball is much more heavier as compared to feather. But if you see, when you see in that container, in that particular house, if there is not even a single amount of air, what we see is that both this ball and the feather, they will reach the ground at the same time. Because in our general life, what we have the presence of gravity and many other factors there, as air resistance. But if we remove that particular air resistance, then these two, that is the ball and the feather, they are going to reach to the ground at the same height. This was the experiment conducted by Galileo's, so which normally says mass doesn't make that much amount of difference there. Is that yeah? So thank you very much. Good morning, students. So yesterday we were learning about mass and weight and acceleration due to gravity. Now today we will move forward with the topic of thrust. Topic of thrust. Okay. So when we talk about thrust is actually a type of force. What is thrust? It is a type of force. Understand? So normally speaking, we have a little amount of concept regarding the force, as we have talked about the force and laws of motion. We have discussed in class 8 that force is a push or pull of an object, and in class 9 we have discussed force is something like a mass and acceleration. Now, what is that force? I will just give you an example here. Let's say this is the surface. This is the surface. Okay? If there is any kind of force which acts in a very perpendicular manner to a surface, we used to call this kind of force as thrust. Is that clear? For example here, if the force is acting downward, then you can see this is the surface here. Let's say this is the ground. And to this ground, if the force is acting in downward direction, you can see there is a formation of perpendicular degree here. This kind of force is what we used to call as thrust there. Now you must be thinking, okay, if we just, about the examples, if we just try to take some example here, let me think of one example here. Let's say this is the ground, okay? And there is a person who is wearing a shoe here. Understand? Now, if you, this is the, a foot of a person, okay? He is applying the force in downward direction there. Understand? For example, when we were walking, we are not applying the force in that direction, but instead we are applying the force on the downward direction so that we can stand. Understand? So when this is forming a perpendicular degree over here, so this kind of force is what we used to refer to as thrust there. Thrust. So in short, how do I define thrust? Thrust is a force which always acts in a perpendicular direction to the surface, is what we used to call as thrust. Clear? Okay, so let us take some example regarding that, right? Okay, yeah, that's okay. Before we go for the example of thrust, we shall study a little bit about the pressure. Understand pressure. So I guess every one of you have heard something about the pressure. But if we just try to give a scientific definition for pressure, pressure is what how we used to define it. It is a force. It is a force acting per unit area is what we used to refer as pressure. But normally speaking, pressure instead of writing force, we used to write pressure is equal to thrust by area. Thrust by area there. Understand? So this is the scientific definition of a pressure. But what is more important for us to understand is that, let's say, okay, generally speaking, okay, when we talk about the definition of the pressure itself, if a particular amount of force is applied in a given unit area, this kind of force is what we used to term as pressure. Understand? We have so many kind of examples regarding that. We will go for it one by one. Okay. So, talking about the unit of pressure, you can also write for whether this is thrust is the force. You can also write Newton per meter square for area, or else the most commonly used unit for pressure is SI unit, is Pascal. Pascal. Understand? So this is the most commonly used unit in the case of pressure, that is Pascal. Understand? Okay. So now, in your exam, okay, what kind of question they used to ask? It's like very rare that they are not going to ask you something like what is pressure, right? But instead, they might ask you which particular example is having more pressure. Okay. So let's have a look. I will just write. Okay. Uh-huh. Okay, so what do you see in that? A two kind of person, two different shoes, right? And they are walking in a desert area. Understand? Let's say this is desert area. Okay. Now my question will be, in which case situation number A or situation number B, in which case the person will find it more easier to walk in a desert, on a desert, right? So let's say this person is having a flat shoes there, understand? Whereas this woman, she's wearing a heel there. Now, in which case do you think a person will be able to walk in a more easier way? Definitely, I'm sure you are going to answer this one there. Is that clear? Why is this happening? Is that because the surface is something like this here, surface, and the pressure is down here, force is applying downward here, which is why we are writing thrust there first. Okay. Now, in this case, how you will be able to answer is that in this case, if you look at the surface of a shoe here, look at the surface of the shoes. It is having more area. It is having the area is more. If the area is more, pressure will be very less there. Why? Because pressure is inversely proportional to area there. But pressure is directly proportional to force, which is acting in a particular direction or the thrust. But pressure is inversely proportional to area there. So, taking this example here, we will study this one here. That is pressure is equal to thrust. Thrust. Understand? But pressure is, is inversely proportional to 1 upon area here. So, what I'm trying to say, if the thrust is more, the pressure will be more. Right? if the thrust is less, pressure is also less. But if the area is more, the pressure will be lesser here. That is the case over here. If you look at the sole of the shoes, it is having a huge area. That is why it is having a very less amount of pressure, so that we find it very easy to walk. But that is it here. In a similar case over here, if you look at the heel here, the pointed heel has a very small area. Small area, that means pressure will be very high, which is why we find it very difficult to walk on a hill, in a hill, on a desert. Understand? Is that clear? So this is the relationship of pressure with thrust and pressure with area there. Is that clear? So let us go for another example here. Whenever we are cutting an onion, we use knife, right? We use knife. Let's say this is a knife here. When we are cutting an onion here, okay? And whenever we are using a knife, we use this side. We don't use this side, even though both are made of metal, hard surface, right? But the point is, why we are using this point is that this over here, this is really sharp, and on that side, this is not sharp. So it's something like this point here. If you look at this point here, this is very sharp, and it means very less area. If the area is less, the pressure will be more, then you can cut it very more easily. But if you look at this point here, this point there is more area, that means less pressure, which is why you won't be able to cut the onion that easily here. That is the case in the case of knife here. Understand? So there are different kind of bags the student used to carry to school. For example, strap bags here. If there are some students who have a bag, they used to strap. Do you know the strap of bag over here? Some students have this kind of straps, bags like this, right? This is your bag here, and this is the back strap. And some students who have a bag, they use a kind of thread like this, thread. Okay? So the point is, if the person who is carrying this kind of like bag, if they are carrying the same amount of weight, kind of like 5 kg something, which is a lot, to be honest, right? If this person is going to feel so much of pain over the shoulder, why? Because if you look at the thread over here, this is having a very less amount of area. If there is a very less amount of area, then there will be more pressure, which is why he will be feeling the pain. But if you look at this particular strap of the back here, it's having a more area, that means less pressure. That is why school bags normally they are made of broad kind of straps there. Do you understand? So this is how we learn about the pressures. Understand? Is that clear? Okay. So now we started with the pressure from the topic of thrust. Is that clear? Thrust normally means any kind of force which is acting in a perpendicular direction to the surface there. Understand? So I'm going to bring another kind of thrust there. Okay? Okay. So there is one question here. Why do object floats? Why do object floats? I guess many of you are having your own answer regarding that, right? Okay. 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 So that is the question over here. Why do object float? Now as you can see, this is the surface here. Why do object float? Whenever an object is immersed in the water, it experiences force from all directions, as you can see here. This direction, this, upward, downward. In every direction it experiences some force. But as you can see, this force and this force are equal in magnitude. That means they are same somehow. So which is why they cancel out somehow. And if you look at this force and that force, they cancel out somehow. This and that, they cancel out. But if you look at this force here, that is the smaller one and the bigger one here, that is the lower one. This is very high. Whereas this is very less, this is very high. Which is why they push the object up. That is why the object floats. Is that clear? Now if you look at this particular force here, I'm going to write here. This particular force is acting upward here. Upward. Understand? Is acting upward here. And this is surface here, and there is a perpendicular here. Is that clear? So this particular force is normally what we used to refer as Buoyant's force, right? Understand? Normally what we used to refer as buoyant force. Understand? Now this buoyant force is also referred to as upthrust force. Upthrust force. Why we are calling this as upthrust force is this particular force is acting in a perpendicular direction to the surface, but this perpendicular direction is towards the upward direction. That is why we are calling this as upthrust. Thrust means perpendicular. That is why buoyant force is also referred to as upthrust force. Is that clear? I hope you have understand something about the thrust, force, and all of this, right? Okay. Hello again. So let us talk about the density. I have written a small picture over here. Let us try to imagine this particular picture as trees here. Trees. This is also tree. Okay. So now, if you look at these two pictures here, let's say A and B here, what you see is that we used to call this as dense forest. This is dense. Why this is dense? Because in that particular area there are a large number of trees are present, and we call this as dense. Now, if you look at this one here, is it dense? No, this is not dense, right? Over here, because in that particular area there are very less number of trees there. Understand? So, from this particular point here, we are having a little idea about what actually is density. So, density, scientifically speaking, how we should define density is mass divided by volume. Understand? In a given volume, how much quantity of mass is present? That is what we define as. That is how we define as density there. For example, there is an iron nail. That is an iron nail. Okay, and there is a box here. Both of them are present on the water. Now, if I ask you what will happen to the box or the iron nail, definitely you're going to answer that this iron nail is going to sink down here, sink, whereas this box is going to float on top there. Even though this box might be more heavier than this particular iron nail, but it floats. Now, when this happens, what is important for us to know is that the density of this in this particular iron nail, in a small unit area, there is a huge amount of particles which are present in that, which is why this iron nail, let's say this is the unit area here. Even in this small area, there is a large number of mass is present, just like over here. Understand? Which is why when you compare the density of this nail and the density of water, this density of nail is much more higher, which is why it sinks down. But if you look at this particular box here, it is having more area and it is having a very lesser number of masses. When you compare the density of this particular box and the density of water is having more density, which is why it floats. On that particular concept, the ships though they are made up of heavy kind of like things, but they are having a very huge area, which is why ship and nail, if you compare the ship and nail, ship are much more heavier, but they floats. Why? Because they are having the area there. Understand? I mean, sorry, they are having a huge volume there. So density is how we define as mass divided by volume there. So normally we refer use the unit kg for mass and for volume meter cube there. So kg meter cube is the unit of the density. Is that clear? Speaking about the density, it is very important for us to understand another principle here, that is the Archimedes principle. Archimedes principle. Now, Archimedes principle, if you talk about the Archimedes principle, Archimedes is a great scientist, understand, who, what do you call, made one particular kind of theory which we used to call as Archimedes principle, understand? Okay, now according to this theory, again, that particular principle, what it was actually trying to say was Archimedes, one day, when he was bathing, okay, in a bathtub which is full of water. This is full of water. Full of water. Understand? And Archimedes, let's say Archimedes, he went into the water. The moment he went into the water, what he came to know is that there are some amount of water which is going to get displaced outside. Some water which is going to come outside. For sure, right? Even in our daily life, we need something like this here. Okay, if I put one finger in the glass which is filled with water, I will see little amount of water which is coming outside. If I put two fingers, I will see more water coming outside. If I put all my finger into the glass, what I will see a great number of water is coming outside. Understand? So this was the particular kind of principle. Through this observation, this guy Archimedes, he made some conclusion which we are going to learn. Understand? So that conclusion was, what he concluded is that the amount of water which is being displaced. Understand? There are three kind of situations which is important for you to understand. Number one, first thing, if an object is immersed fully or partially. Understand? What is it? Number one is fully or partially. Number one, whenever an object is immersed fully or partially, partially means half, right? You will see some amount of water displacing outside. Understand? That is number two. Displaced. The water will get displaced, definitely, right? Let's say, suppose this is my finger. Let us take this example here. Whenever an object is immersed, that is the first one, immersed, there will be some of water which is going to get displaced. That means some water is going to get displaced. Understand? But we have learned in the previous topic about the buoyancy force. Whenever an object is present in a water, there is a presence of an upthrust force, also buoyant force. Understand? That is the one of what? Force. So now these three are the things which is important for you to know that before we conclude. Understand? What object is immersed fully or partially? Number one. Whenever there isn't presence of an object which is immersed fully or partially, there are some water which is going to get displaced. And to that object, there will be some force applied. Understand? So now let us conclude. Okay? So, according to Archimedes' principle, what he concluded is that here. Okay, so I'm going to put a 5 kg stone in that, 5 kg. When I put 5 kg stone in the water, I will see some water coming outside. And maybe water level could be somewhere in this region over here. Water level. Okay? Water level to this much region over here. Now, according to Archimedes, what he said, when an object is immersed fully or partially in a water, the water will get displaced, and this water displaced, the displaced water, that is this water here, is equal to the upward force applied in the direction, upward direction of the. This is what we call as Archimedes' principle. Understand? According to Archimedes, again I'm saying it, when an object is immersed fully or partially in a water, the amount of water will get displaced here. This amount of water, the weight of this particular amount of water, is equal in magnitude to the upward force. Is that clear? Do you understand Archimedes' principle? If you check the weight of this particular water and the magnitude of this force, they are somehow same. This is what the Archimedes was trying to say. Is that clear? There is a background story regarding that, which I guess many of you are quite familiar with, right? Okay, so this is about the Archimedes principle. It is important for you to know this 3 point over here. Object immersed fully or partially. The water will get displaced, and the upward force and this water is same. These two are same when this condition arises. Okay? Thank you.